the further lecture of ratio and proportion. Today we will be seeing the first practice set of this chapter, practice set 4.1. So let us see what we will be seeing in practice set 4.1. I will be dividing this practice set 4.1 in two videos. First we will be seeing the first, second, third and the fifth question, and in the further video we will be seeing the fourth and the rest questions that will remain. So let us start with our practice set. So the first question in practice set 4.1 tells us bringing the ratios given to us in the simplest form. Now how is that supposed to be done? Let us see. The first sub question of the question number 1 of practice set tells us to bring the ratios in the simplest form. So let us see. First question given is 72 is to 60. First thing that we do is bring this in the division form, that is 72 into 60. And to find the simplest ratio for this equation, we will be doing some prime factors calculation. We all know how to calculate a prime factor of these numbers. So let's see. First we will consider 72 and then we will be considering 60. Dividing 72 by the lowest prime factor 2. What I get is 2, 3s are 6, 1 of that is remaining. So after 6 goes, 1 remains and 2, 6 will give me 12. Again dividing it by 2, I will get 2, 1s are 2. After that 1 remains again and 2, 8s are 60. Further 2 9s are 18. And last, as we all know, 9 cannot be divided by 2. So the only prime factors for 9 are 3 multiplied by 3 and 3 multiplied by 1. As soon as we reach to the factor 1, we will be stopping to find the prime factors. Now, similarly, we will find the prime factors of number 60. 2 divided by 30. Then 2 15s is 30. Now, after that, we cannot divide the number 15 by 2. So, next prime factor is 3. And 3 5s are 15. And 5 1s are 5. So, these are the prime factors for number 72 and 60. So, we will be writing this is equal to 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 divided by these prime factors will come 2 multiplied by 2 multiplied by 3 multiplied by 5. Now I have got the prime factors of the numbers. So what I am supposed to do is cancel, that is deduct the numbers similar in numerator and denominator. So 2 and 2 will get cancelled. One more 2 and one more 2 will get cancelled. Now 2 and there is no other 2 in the denominator, so we cannot cancel the 2. We will move on to the further number. So next number is 3 and denominator 3 also gets cancelled. Now you can see 2 cannot get cancelled, 3 cannot get cancelled and neither can 5 get cancelled. So what I am left with is 2 multiplied by 3 upon 5, which is equal to 6 upon 5. So 72 upon 60 is equal to 6 upon 5. Moving on to the second sub question of the same question, question number 2. 38, 57. 38, 57. So we have 38 divided by 57. We'll now move on to the further part of the board where we'll see division of, we'll do it here itself, 38, and here I will do it by 57. As you can see, there is a unit place having even number, so we can divide this number by 2. So dividing by 2, I'll get 2 ones are 2. 1 from the 3 is remaining, will go with 8 and I will get 9. So I will have the number 19. And what is number 19? It's a prime number. Hence, we cannot divide this 19 number to further prime factors, and hence our factors for 19 are 19, ones are 19. Seeing 57, unit place has an odd number, hence 57 cannot be divided by 2, and what we have is we have to divide it by 3. Divisibility of 3 is adding the 2 digits, that is 5 plus 7 will give me 12. And 12 is divisible by 3, hence 57 will also be divisible by 3. That's it. So 3 ones are 3, and when 3 is removed from 5, I have 2 remaining, and 2 and 7 makes it 27. So 3 nines are 27. Again, my common prime fact number 19 has come, so I cannot divide the number ahead. So 19 ones are. Here I will be writing it as 2 multiplied by 19, and in the denominator it will be 3 multiplied by 19. Is as simple as that. 19 and 19 will get cancelled, so my number can be written in the simplest form, 2 divided by 3. That is how you have to solve the first main question of the practice set 4.1. The third question in this practice set will be an assignment for you. Now let's see the second subset, second question of the practice set. Find the reduced form of the ratio of the first quantity to the second quantity. Let's see on this side of the board. First I have 700 rupees and 308 rupees. So main question 2 and sub question 1. 700 rupees and 308 rupees. Now let us see how we can do the find the ratio for the same. Removing it in the denominator and numerator form, I have 700 divided by 300. All that matters here is the unit should be same. In the first question we did not have any unit, but now we are having units, and since both the units in this question are rupees, we will not be converting any unit into any other unit. So 700 divided by 308 rupees. So what can we do now? Let us again do the same method where we will be finding the prime factors for these numbers. So 700 and 308, right? So I have dividing it by 2, I will get 350. Further dividing it by 2, I will get 175. Now it cannot be divided by 2, so the next option that I have is dividing by 5. Since unit place has 5 number, so it is a divisibility of 5, and I can divide this number by 5. So dividing by 5, I get 5 3s are 15 and 5 5s are 25. So next number that I get is 35, and 35 as we all know is 5 7s are 35 and 7 1s are 7. So my factors for 700 are 2, 2, 5, 5, 7. Let's go on to the next number, dividing it by 2 again, as 8 is in the unit place. So 2 1s are 2, 2 5s are 10, and 2 4s are 8. So the next number that I get is 154. Dividing this number ahead by 2, I will get 77. Simple number, 7 into 11, and 11 ones are 11. So these are my factors for 308. Now let's write them in the numerator and denominator form. So I have 2 multiplied by 2 multiplied by 5 multiplied by 5 and 7 divided by 2 multiplied by 2 multiplied by 7 into 11. Now let's check the cancellation of what we have. 2 and 2, 2 and 2. 5 is not there in the denominator, so we cannot cancel 5. So the next number I have is 7 and 7. This is what I am left with, and hence my number gives me 5 into 5 divided by 11, which is equal to 25 divided by 11. So my first number, that is rupees 700 divided by rupees 308, will give me 25 is to 11, which is equal to 25 is to 11. The column represents is to, and this is how we write a ratio. Next sub question that we will see in this question is sub question number 4. Let us see. Sub question number 4 has 3 years and 4 months. And the ratio that we are supposed to find this number is 5 years and 8 months. For this, as I told you in the previous question, the units here were same. But here the units are different, years and months. I have to bring all the numbers in the smaller value, that is months. Years is a bigger value, months is a smaller value. So I will be converting these numbers into months. So first number that I have is 3 years plus 4 months, which will give me 3 into 12 plus 4 months. 1 year has 12 months, so 3 into 12 will give me 3 years, and plus 4 months that I have, which will give me the value 12 is 36 plus 4 will give me 40. And the next question that I have, next number is 5 years plus 8 months, which will give me 5 into 12 plus 8. So I have 5 into 12 is 60 plus 8, 68 months. Okay. Now the numbers that I have are both the values in months. So let us now find the ratio of 40 months is to 68 months. Okay, now again finding the prime factors for these numbers 40 and 68. Let us see what can be done. 2 divided by 20, 2 divided by 10, 2 5s are and 5 1s are. Right? Next number is 2 3s are and 2 4s are. So I have 2 into 34 is 68, then 2 into 17 is 34, and 17 being a prime factor will not have any number, so 17 1s are is 17. So all the factors that I got here are 2 into 2 into 2 multiplied by 5 divided by 2 into 2 into 17. Now let's check what we can cancel over here. So I have 2 and 2 getting cancelled, 2 and 2 getting cancelled. Neither is another 2 over here in the denominator, neither do I have 5, neither do I have 17. So all the single numbers will remain, and I have 2 into 5 divided by 17, which will give me 10 divided by 17. This is how we do the second sub question, second main question in practice set 4.1. Now, as I erase the board, please I will ask the students to read the third main question of the practice set 4.1, where we have to express the following numbers in percentage, the following percentages into their reduced form. So let's see. Question number 3, question 1. So now I have 75 is to 100. Now this percentage, as we know, whenever we have denominator 100, then the number is a percentage. Now 75 is to 100. 75 and 100 are very easy to be calculated to a reduced form. As we know, 75 and 100 are both factors of 25. Hence, 25 multiplied by 3 gives me 75, and 25 multiplied by 4 gives me 100. So the factors of 75 are 25 and 3, factors of 100 are 25 and 4. Now I will be doing the cancellation, which is very simple, and the number 25, numerator and denominator, will get divided, and hence what I am left with are my answer, that is 3 upon 4. Therefore 75 is to 100 will give me 3 is to 4. This is how we do the reduction of percentages. Let's see the third sub question in the practice set. Sub question 3. Here I have the number 6.25%. Now when I have a number 6.25%, first I have to write it in the form divided by 100. So I get the value as 6.25 divided by 100. Now having a decimal point is quite complicated to solve. So here's a trick how you can solve the numbers given here. If you see, I have a decimal point after 2 decimal points. So if I have to remove the decimal point, what do is I add 2 zeros in the denominator. So this number gets converted to 625, and I already had 2 zeros in the denominator, and add 2 more zeros, and which will make the number as 100 multiplied by 100, isn't it? 2 zeros is not just zeros, but the number with 2 zeros, that is 100. And when I add one more 100, then my decimal point that was after 2 decimal places gets removed, and I am left with 625 upon 100 into 100. Now the trick here is, this will be very easy for you. See, 625, what is the square root of 625? It is 25 multiplied by 25. 625 is 25 multiplied by 25, and denominator, as I already have, is 100 multiplied by 100. Now taking only this and this, we'll get 25 ones are 25, 25 fours are 100, 25 ones are 25, 25 fours are 100, and this is how I get the value of the reduced form, that is 6.25% is equal to 1 multiplied by 1 is 1, and 4 multiplied by 4 is 16. So my ratio here is 1:16. Now similar questions are there in the whole of question number 3, and hence I think that these sums can be given to you as an assignment. Now skipping the fourth main question of the practice set, let us move on to the fifth question of the practice set, as we will be doing fourth question and the remaining questions in the next video of depending upon this chapter. So let's see how to do the question 5. Let us begin question number 5. And first sub question for this practice set in question number 5 is 15 is to 25. In the third question, what we did is we reduced the percentages to smaller number. In this question, what we are supposed to do is we are supposed to convert this number into a percentage. So for that, the basic that we want is the denominator should be 100. So if we want the denominator should be 100, I have to multiply this denominator given to some number, and that will give me 100. So let's see, 15 divided by 25. is equal to, what will we have to multiply? 15 upon 25 to get it as 100. I will write 15 divided by 25. Right? What do I have to multiply? To 25, that is our denominator, to make it 100. That's right, I have to multiply it 4. So if I am multiplying the number 4 in the denominator, the same number should be multiplied in the numerator, and hence I have 25 multiplied by 4 upon 15 multiplied by 4. Now the number that I get is 15 4s is 60 and 25 4s is 100, and hence 60%. As easy as it can get, these numbers are very easy to solve. Converting into percentage is very easy. Now, if you all see the further sums, they are quite easy. I will show you how to do the last sub question in this main question 5, as it is a little bit different from the other 4 numbers. So I have sub question 5, 7 upon 16. For this number to get converted into 100 in the denominator is not possible, as 16 is not a factor of 100 and 16 cannot be multiplied to any number to get it as 100. So what we'll have to do is we'll have to see if 16 is divisible to any number that will bring me hundreds multiple. That is, either it can be 100, it can be 200, it can be 300, it can be 400, it can be any other number simultaneously. 16 1 is 16, and 16 into 5 is 80. Right? So I can get 800 as the multiple of 16. So when I multiply 7 upon 16, multiplying this number into 50 and this number into 50, I will get the numbers as 7 5 is 30, 5 and the 0 upon 800. So now I have 350 upon 100. So the new number form is 350 into 100, which is equal to, now a fun part, 350 upon 100. Now this number, if I convert it to 100, what do I do? Instead of multiplication, I will do division. So now I get 350 upon 800 divided by what? 8. 800 divided by 8 will give me 100, and 350 also I have to divide it by 8. Hence the denominator that I get is 100. Now let's see what my numerator will be. So for that simple division, 350 and 8. 8 4 is 32. Subtraction, I get 3 and 0. 8 2s are, 8 3s are is 24. I am left with the remainder 6. Now a decimal point comes in and I have 0 in the remainder, and hence my number ahead will be 8 7s are 56, remainder 0, and I have to add there, I get 5 the 40, and hence now my remainder comes to 0. So my percentage here are 43.75. Therefore 7 is to 16 is equal to 43.75%. This is how I convert smaller numbers to percentages. In the first question that we saw, we had to bring the numbers to a reduced form. In the second number, same numbers included units. In the third question, we saw how to convert percentages into smaller numbers. And in the last question that we saw today is how to bring smaller numbers into their percentage form. This is all we have for today's video. I hope that you have completed the assignment for the same, as I have not explained all the sums in this practice set. We will be continuing the remaining main questions, that is question number 4. Hello students, welcome back to the next part of ratio and proportion. Today, as I promised in the previous video, we'll be seeing the second part of practice set 4.1. In the previous video, we saw the first, second, third and the fifth question of the practice set, and today we'll be seeing the rest of the questions, that is question number 4, 6, 7 and 8. So, how about we start it? So, the question is, 3 persons can build a small house in 8 days. To build the same house in 6 days, how many people will be required? The question tells us that it's an inverse proportion, because we saw in the introductory video that the number of people increase, the labor and the time decreases. So if the people building the house increase, the days that will be required to build the house will decrease. So as it is asked, it is an inverse proportion. So let us see, 3 people build the house in 8 days. So let us consider the number of people to build a house in 6 days is x. So how will we finding it out? Now, being an inverse proportion, we know that 3 will be proportional to the inverse of this number. So hence 3 upon x is equal to 6 upon 8. As it is the inverse proportion, we will be inversing one of the ratios in these numbers. So now we have the proportional, inversely proportional ratio in front of us. So let us see how it is done. I will be cross multiplying. So 3 is multiplied by 8 and 6 is multiplied by x. Calculating this, I will get 3 multiplied by 8. We will multiply and find out the value for 3 multiplied by 8. So we have 3 8s are 24 is equal to 6x. Now as we did in simple equations forms, we will just have to bring the 6 that is multiplied to the x to the other side, and we will have x is equal to 24. This multiplied 6 will be divided, and therefore x is equal to 4 days. Hence 6 days will be taken by 4 people to build the same house. This is very easy sum and clearly understandable sum. The question was 3 people take 8 days. So x people take 6 days. By calculating it with inverse proportional formula, we get the value as x is equal to 4. Hence, the days people required are is equal to 4. This is how the fourth question of the practice set is solved. Now read the fifth is done. So we will read the next question, that is sixth one. The ratio of ages of Abha and her mother is 2:5. At the same time, at the time of Abha's birth, her mother's age was 27 years. Find the present ages of Abha and her mother. So let us see question number 6. The ratio of the ages is 2:5. First thing that we consider when we have a ratio is we consider the common multiple. So at present the ages are in the ratio 2:5. Let common multiple, that is the number that will be multiplied it to 2 and 5 to get the present ages. So let our common multiple be x. Therefore Abha's present age is 2x and mother's present age is 5x. So these are the present ages, that is 2x and 5x. When I get the value of x, I can say by multiplying it to 2, that will be Abha's present age, and multiplying it by 5, that will be mother's present age. But what do they tell us? Okay, at time of Abha's birth, her mother was 27 years old. So at time of her birth, that is present age of mother minus her birth, that is the age of Abha. Her age was 27. That's right. We get present age of mother minus Abha's age, as her birth, the time of her mother birth was 27. So 5x minus 2x is equal to 27. So I have 7x, sorry, not 7x, I won't get 7x, I will get 3x is equal to 27. Therefore, x is equal to 27 divided by 3 and x will give me 9. So my common multiple that I will be multiplying to 2 and 5 is 9. Therefore, Abha's present age is 2x, which is equal to 2 multiplied by 9, that is 18. And mother's present age is 5x, which is equal to 5 multiplied by 9, that is 45 years old. This is how we calculate the present ages of Abha and as well as her mother. Hence, we are done with the 6th question of the practice set. Now, as I erase the board, I will request you all to read the question that flashes on the screen, question number 7, for the further calculations. Question number 7 is, present ages of Vatsala and Sara are 14 years and 10 years respectively. How many years later the ratio of the ages will become 5:4? So present ages for 7th question, the present ages of Vatsala and Sara are 14 and 10 years respectively. So let x be the number of years when ratio will be 5:4. So we consider that x is the years that added to. So as I told you, x is the after the exact number of years after which the ratio of the ages will be 5:4. So the ratio of the ages is 5:4. That's right. And the present ages are 14 years for Vatsala and 10 years for Sara. Now I have to add x number of years to both their ages. So plus x and plus x on both numerator and denominator. Now this ratio, that is present ages plus x years, is 5:4. Now simple cross multiplication to be done. 4 into 14 plus x is equal to 5 into 10 plus x. Now just calculating it, 4 into 14 will give me 56 plus 4 into x is 4x is equal to 5 into 10 will give me 50 plus 5 into x will give me 5x. Now bringing like terms together, that is numbers with x as the coefficient will be on the one side and variables will be on the other side. So 4x minus 5x is equal to 50 minus 56, bringing 56 on this side. So I get minus x is equal to minus 6. Therefore, x is equal to 6. This is exactly the number of years after which the age is 14:10. 14 and 10 will become into ratio 55:4. This is how the 7th problem in practice set 4.1 is done. Now let us see the final problem in practice set 4.1 with which we will conclude today's video. So let us see. Read the question 8 of the practice set 4.1. The ratio of present age of Rihanna and her mother is 2.7. After 2 years, the ratio of the ages will be 1:3. What is Rihanna's present age? Think of how we are supposed to do this sum. Till then, I will clear the board for us to do this last practice problem in the practice set. So, the present ages are in the ratio 2:7. So, let us see 8th one. Present ages ratio is 2:7. After 2 years, the ratio of the ages will be 1:3. What is Rihanna's present age? Now, for this to be done, as you all know, when the ratio is given, we will first consider a common multiple. So, let x be the common multiple. That's right. Now we will consider x as the common multiple. So Rehana's present age is 2x and her mother's present age is 7x. This is what we have from the given ratio. Now they tell us after 2 years their ratio of their ages will be 1:3. So after 2 years, which means present year age plus 2 years. Therefore, present age of Rehana is 2x plus 2 years and present age of mother is 7x plus 2 years, and this brings the ratio is 1:3. Now here if you see, this question is a combination of question number 6 and question number 7. In question number 6, we saw a common multiple to be calculated to find a value. In question number 7, we saw the ratios, two different ratios being formed, as you can see right over here. So this question is exactly the combination of this question and the previous one. So let us calculate this question. So I get 3 multiplied by 2x plus 2 and 1 multiplied by 7x plus 2. Okay. Calculations, 3 into 2 will give me 6x plus 3 into 2 will give me 6 is equal to 7x plus 2. Now bringing the like terms together, 6x minus 7x is equal to 2 minus 6. Bringing the calculations, I get minus x is equal to minus 4. Therefore, x is equal to 4. Now I got the common multiple x as 4. But what am I asked in the question? I have to find Rehana's present age. So I know Rehana's present age is 2x. Therefore, Rehana present age is equal to 2x, which is equal to 2 into value of x is 4. So 2 into 4, and which will give me the value 8. Hence, Rehana's present age is x. This is how the sums for ratio and proportion are supposed to be done. Hello everyone, welcome back to my channel Science and Math with Gerard. And today we will be studying the further topic in the chapter ratio and proportion. As you can recollect, we did half the exercise practice set 4.2 in the previous lecture. But as I realized that the remaining of half that we have skipped is already reduced from the portion. So we will not be doing the remaining 2 questions that are there for the practice set, and we will be moving ahead with our portion for the chapter. So what we will be seeing today, we will be seeing operations on equal ratios. So first thing that we will study today are what are equal ratios, and after that we will be studying on how we can operate on this equal ratio and how to solve the equal ratios. As you can see, I have made a whole new structure on the board in front of you, and we will be seeing what exactly are equal ratios. With the term equal ratios, we understand what they actually are. Equal ratios are the two ratios that are equal to each other. As you can see, A upon B is equal to C upon D. Now, if we talk about example, if I write an example over here, what is the example? 1 upon 2. If one of my ratio is 1 upon 2 and the other is 2 upon 4. Now, this 2 upon 4 can actually be cancelled. That is 2 ones are and 2 twos are, and this another ratio also gets converted to 1 upon 2. This is how the ratios actually operate. So this is how we get the answers for our ratios, and this type of ratios are called equal ratios. So now we'll learn what are equal ratios. Now let us start with operations on equal ratios, that are how to calculate the equal ratios. First operation, that is first kind of a calculation that we can do on equal ratio, is inverted. The word invertendo has the short word invert, which means we can invert the ratios. So first is, if we have two equal ratios that are A upon B equal to C upon D, then these ratios after inverting, that is denominator comes in the numerator and numerator comes in the denominator, and this type of ratios are called B are also equal. So if two ratios are equal, then the inversion also becomes equal. So A upon B equal to C upon D, then B upon A becomes equal to D upon C. If 1 upon 2 is equal to 2 upon 4, then inverting 2 upon 1 also equals 4 upon 2. This is how we can calculate the equal ratios with the help of inverting. That was the first operation of inverting. Now moving to the second operation. Second operation is alternando. That has the word alternate. Alternate ratios. If you can see, I have taken two ratios again. A upon B is equal to C upon D. Then alternating that means transferring each other's numerator and denominators. Now these numbers get converted to A upon C. The C of the second ratio comes to the first ratio, and B of the first ratio goes to the second ratio's numerator. So my new ratios that are formed are A upon C equaling B upon D. This is what alternando does. Alternando means we change the alternate numbers of the equation or the ratios. Now examples are 1 upon 2 equaling 2 upon 4. Then by alternating 1 upon 2 again becomes equal to 2 upon 4. Even if I change the numbers, I get the same value. If I change the numbers, what I did here was the example with the same number. Now let us see if I have 1 upon 2 equal to 3 upon 6. 3 ones are and 3 twos are also become 6. So similar to this will also be equal to 1 upon 2. After alternando, what I get is 1 upon 3 equaling 2 upon 6. Now these two ratios also become equal. This is the operation alternando. These are the basic operations on the equal ratios. Now we move on to the more important ones and the most used ones, operations in the equal ratio. Componendo. Take a look. The ratios that I have again are A upon B equal to C upon D. Now what does componendo do? Componendo adds the denominator to the numerator. So by componendo what we get is A plus, that is numerator plus denominator upon denominator of one ratio is equal to numerator plus denominator upon denominator of the second ratio. This is componendo. Componendo means in one ratio, if I add the denominator, then in the second ratio also I will have to add the denominator. This is what we have for componendo, and exactly opposite of componendo is alternando. Here we added the denominator, here we will be subtracting the denominator. As you can see, the two ratios that I have, that are A upon B is equal to C upon D. Therefore, the new ratios that I found by subtracting denominator of first ratio and second ratio. A minus B divided by B. In first ratio, numerator minus denominator upon the denominator gives me numerator minus denominator upon denominator in the second ratio. So whatever happens to the first ratio happens to the second ratio. This is how equal ratios function. The functioning of equal ratios is same. So whatever happens to the first ratio happens to the second ratio. Now last and the most important operation of the practice set that we will be seeing ahead and the equal ratios is componendo dividendo combination. The combination of these two operations and combined together we get the operation componendo dividendo. Now let us see what exactly do we do in this operation. In componendo you added the denominator. In dividendo you subtracted the denominator. And now in this combo what you do is you combine both of them. So in the numerator is added, in the denominator it is subtracted, and hence Now how do we get that? By actually dividing this equation by this equation, I will get the values that are a plus b divided by a minus b, and this both b's will get cancelled in the denominator. Similarly, both d's will get cancelled in the denominator, is equal to c plus d upon c minus d. A plus b upon a minus b equals c plus d upon c minus d. These are all the operations that I wanted to introduce to you all for the further practice sets of this chapter. So practice set 4.3 is completely based on the 5 operations that we saw now, and there is no sum that is reduced from the syllabus for this practice set. So we will be doing this practice set in detail, and if possible I will be completing the practice set in the next lecture. Thank you for watching the video and understanding what operations on equal ratios mean. Stay tuned for more such fun videos, and in the next video we'll see how to actually have fun with all these operations and how to understand them. Hello students, welcome back to another video for the chapter Ratio and Proportion. In the previous lecture we saw end of practice set 4.1. So today we will be seeing the concept of comparison and operations of ratio, and also the practice set 4.1. So in this practice set itself we understand what are comparisons and operations on these ratios. So let us start and begin with the new practice set 4.1 for this chapter. See, the first question asked is, using the property of a upon b is equal to ak upon bk, fill in the blanks, substituting proper numbers in the following. So let us see what exactly does this question mean. So they are given us a upon b is equal to a into k upon b into k. Now what does this mean? This means that k is the common multiple for this question. I will be solving the first sub question in this main question, and second question for this main question will be the assignment for you. So let us see what exactly are we supposed to do. Here instead of a upon b, we are given 5 upon 7 is equal to dash. The upper number is not given. We are given 28, which is equal to dash. We are given 35 in the numerator, and on the next number we are given 3.5. So let us see what exactly are we supposed to do. I will just mark the blocks that are given to us. This will be a blue, this will be a blue, and this will be a blue. So we are supposed to find 3 values that are unknown to us. So let us see. First we will consider the first 2 columns. 5 upon 7 is equal to dash upon 28. You exactly know what does 7 and 28 relate to, which is equal to 7 multiplied by 4. Hence the above number will also be 5 multiplied by 4, which is equal to, which will give me 20 upon 28. When I multiply denominator 7 by 4, I get the value 28. So here is my value 28, and hence the numerator that I got is, when I multiply 4 in the denominator, the same number will be multiplied in the numerator, and hence my new value is 20. Similarly, let's see the first and the third ratio. I am given 5 upon 7 is equal to 35 upon an unknown number. Now, in the first case we knew the denominator, in this case we know the numerator. We know that 5 upon 7, now I want 35. 5 into something will give me 35. Exactly as you can imagine, 5 into 7 is equal to 35. So my new value is 5 into 7. So denominator will also have 7 into 7. Same number is to be supposed to be multiplied on both the places, that is numerator as well as denominator. Hence my new value is 35 upon 7 into 7 will give me 49. As you can see, the numerator 35 is satisfied, and hence the denominator that I get is 49. The new value that I will get is 49. Now the last section of this practice question, I will consider 5 upon 7, that is the first ratio, and the last ratio, that is box upon 3.5. In the first two cases, as you all saw, I had a proper whole number as my answer. But in this case, that is not what you will observe. You can see there is a decimal place. But as simple as it can get, you know 7 5s is 35. So 7 multiplied by 5 will give me 35. But same way, 7 into 0.5 will give me 3.5. So my denominator 7 is multiplied by 0.5 to get me 3.5. Similarly, 5 will be multiplied by 0.5, and hence my new values are 2.5. That is 5 5s are 25, and because of the decimal place I have 2.5, and this will be 3.5. So denominator here in this part is satisfied, and hence my numerator that comes out is 2.5. Is that very easy? This is how you are supposed to solve the second practice set ka first question. Second sub question in this practice set is for you all to do as the assignment. Now let us move on to question number 2 in this practice set. Question number 2. Read it out, please. Find the following ratio. Now here we are supposed to create our own ratios. The ratio of radius to circumference of the circle. So first thing that we consider is let R be the radius. Circumference is equal to, what is the formula for circumference of the circle? It is 2 pi r. So r being the radius and circumference becomes 2 pi r. Now required ratio is equal to, what is the ratio asked? Radius to circumference. So r to circumference, that is 2 pi r. Now with this we get to cancel r and r from numerator and denominator. So my ratio is 1 upon 2 pi. Therefore required ratio is equal to 1:2. This is how you calculate and find a ratio. See the third sub question in this question number 2. In the third sub question in this question number 2, we are told the ratio of diagonal of the square to its sides if the length of the side is 7 centimeters. So what we are given in this third question is length of side is equal to 7 centimeters. So length is given and we are supposed to find the ratio of its diagonal to its side. So for diagonal of square is equal to question mark. But we know we have a formula for the same. Therefore diagonal of square is equal to root 2 multiplied by side. We already know the side is root 2 multiplied by the side, as we know, is 7. So root 2 into 7, which will give me 7 root 2. This is the value of diagonal. Therefore required ratio is equal to diagonal to side. So 7 root 2 upon 7. Side is 7, diagonal is 7 root 2. doing the cancellation that are required, I get which is equal to root 2. Therefore, required ratio is equal to root 2 is to 1. This is how you are supposed to calculate second main question in practice set 4.2. The rest two sub questions that remain, that is question number 2 and question number 4, are for your as an assignment. Now let us see practice set 4.2's third question, where we will see the comparison of two ratios. For that I will erase the board. Till then you will go through the questions. So as you can see on the board, I have written some things related to comparison of ratios. The topic that I had written in the beginning, comparison on operations on ratios. So here are the two ratios given to us. One is A upon B and the other is C upon D. Then if my cross multiplication, that is A into D and B into C, if AD is less than BC, then A upon B is less than C upon D. Hence, cross multiplication is the major thing in comparison. Similarly, if it is equal, then the ratios will also be equal. And if it is greater than BC, then this ratio, first ratio, will be greater than BC. So, let us see how we can solve these questions and how we can compare the ratios. First main question, sub question is root 5 upon 3, comma 3 upon root 7. Now here we are supposed to calculate the numbers. Let us see how we can do it. Root 5 multiplied by root 7. We don't know what it is, so we'll write a question mark, and 3 multiplied by 3. Now you can see root 5 into root 7 can be multiplied by 35. Right? So we have 5 into root 5 into root 7 is 35. Here we don't have a question or anything, so we will have a question mark, and this will be 9. Now 9, as we know, is the root of 81. So when I write under root 81, I get the value 9. So what I did is I converted both the numbers into a ratio, and hence now my 35 and 81 can be compared, which are both under the ratio, and 35 is obviously less than 81. Hence my ratios root 5 upon 3 is less than 3 upon root 7. This is how comparison is supposed to be done. Let's see sub question 4 in this question. I have root 80 divided by root 48 and root 45 divided by root 27. So root 45 divided by root 27. These are the new ratios that we have in sub question 4. Now, how are we supposed to do it? Simple. Again, we'll do the cross multiplication. So, root 80 multiplied by root 27. We don't have anything to resemble, so we'll write a question mark. And root 45 multiplied by root 48. So, if we calculate this, we'll get bigger numbers. So, let us not calculate it, but bring it into their factors. As you know, 80 can be written as 8 into 10, right? Or else we can also write it as under root 8 into 5 into 2. 5 2s are 10, which I wrote previously, and this 8, and similarly 27 can be written as 9 into 3. Now let us not compare it. We'll have a box over here, and here I have in this bracket is 45, that is 9 into 5, and 48, that is 6 into 8. Now let us compare both the all the roots under this. 8 and 8 are similar on both the sides. 9 and 9 are similar on both the sides. 5 and 5 are similar on both the sides. Similarly, here we are left with 2 and 3, that is 6, and here also we have 6. So what we conclude is both the sides on this ratio are equal, and hence my ratios that are given to me is root 80 upon root 48 is equal to root 45 upon root 27. Hence, I get the comparison for this ratios. This is how comparison of ratios is done. Now let us move on to question number 6 of the practice set, because we will be completing this practice set in 2 videos. So hence, I will be doing question number 6 now and 7. Question number 4 and 5 will be done in the next video related to this topic. So let us read question number 6. Question number 6 tells us if under root 0.04 multiplied by 0.4 multiplied by a is equal to 0.4 multiplied by 0.04 multiplied by root b, then find the ratio a upon b. So here we are supposed to find the ratio a upon b. So let us see how this question, which is marked star as a complicated one, can be done in a very easy manner. Let us see what we can do for this. So what are we given over here in this 6th question is, let us start. We have under root 0.04 multiplied by 0.4 multiplied by a, not a, which is equal to, I have 0.4 multiplied by 0.04 multiplied by b. This is what I am given. And what am I supposed to find? To find a upon b. What can I find from this? Let us see what we can do. I have root and I have root over here. So if both the places have root, what first thing that I do is squaring both the sides. So when I square both the sides, the root that is there for this term will be removed, and what I am left with is 0.04 multiplied by 0.4 multiplied by a. And on this side, these two terms don't have any square root. So when I square this, I will get 0.4 the whole square multiplied by 0.04 the whole square into root b will be converted as b. Why is this happening? Because I have taken square on both sides. So taking square on both sides, I got these values. So as I know, I want the ratio a upon b. So multiplied b, when it comes on this side, I will get divided by b, and rest everything will be converted on this side. First thing, I have 0.4 the whole square multiplied by 0.04 whole square. This is what I had in the numerator on this side, and this thing will go on other side as the denominator. So 0.04 multiplied by 0.4. Now if you have observed the numbers, it is quite clear that one term from this square and this new denominator will get cancelled. Similarly, second term from this, first term from this square and this term will get cancelled. So out of the squares, one term has gone. So what I have left is the answer to this, that is a upon b is equal to 0.016. I multiplied 0.4 and 0.04, which can also be written as 16:1,000, because 3 decimal places after the decimal point, hence 16 divided by 1000. This is how we calculate the 6th question of the practice set 4.2. A star mark question, and what we have to do is only 4 steps. Now let us see the last question that is there in the practice set, that is practice 7. Here I am given two different ratios. X plus 3 is to x plus 11 is equal to x minus 2 divided by x plus 1. Let us see. X plus 3 divided by x plus 11 is equal to x minus 2 divided by x plus 1. Now here two different ratios are given to us. So the first thing that we do is we cross multiply. Whenever we have such kind of numbers and such kind of ratios, first basic thing that we do is cross multiply. So here I am doing is x plus 3 multiplied by x plus 1 is equal to x minus 2 multiplied by x plus 11. This type of questions we have solved since standard 6. In lower standards also we have been coming across this type of questions when two brackets are to be multiplied. So here I will multiply x into x plus 1 plus 3 into x plus 1, which is equal to x into x plus 11 minus 2 into x plus 11. These are all the basics that we have studied in the lower classes. So let us see what we can find out. X squared plus x plus 3x plus 3, which is equal to x squared plus 11x minus 2x minus 22. This is what we get after opening up all the brackets. So if you observe both the sides, similar numbers can be cancelled. So x squared and x squared, we get rid of both the x squared terms. And as we saw yesterday also, that like terms are to be brought on one side and numbers are to be brought on the other side. So x plus x, 3x will give me 4x. 11x minus 2x will give me 9x on this side, which I bring on this side, I will get minus 9x. I am left with minus 22 on this side and minus 3 on the other side. Plus 3 will get converted to minus. After calculating, I get 4x minus 9x will give me minus 5x is equal to minus 25. Therefore, x is equal to minus 25 upon minus 5. Minus signs will get cancelled and 5 ones are and 5 5s are. Therefore, the question that was asked is find the value of x and x is equal to 5. This is how I calculate the question. Thank you for watching this video. That is the first part of practice sheet 4.1. Tomorrow we will be seeing the second part, that is the two questions that I have left out from solving this practice set, and in the further videos we will be completing the chapter ratio and proportion. Stay tuned for the more such funny and entertaining methods to learn maths, not learn maths, understand maths, because maths is not to be learned but to be understood and have fun with. Thank you.